Good evening. Let's take a look at lesson 4.62 solving equations worksheet. On this first side, you're actually asked to sketch a graph of the equations and to figure out the solutions by partially looking at the graphs and then showing how you can do it algebraically. So if I look at this first one, if I want to graph it, what's going to happen here is I'm going to take the first part of the equation, enter it in my y1, and enter the second equation in y2. So I take out my graphing calculator, have it right here, go to my y equals button right there. I was already on the screen, but just want to show you where I'm hitting y equals. And I'm going to enter in parentheses, x plus 5 quantity squared. So I have that in. Go down to the next one, so I hit my down arrow, hit the 9. Now what I can do is hit graph. Now, I have this invalid dimensions. This might happen to you if you go to your stat plot menu. So, whoops, I got to quit out of it. So if I go second y equals, my stat plots, just means I got a stat plot on. So I'm going to select number 4 and turn off every single one of my stat plots. That way when I hit graph, right, still not having any luck right now because, you know what, my window isn't set. So what I'm going to do is if you look at the grids we give you, we basically give you what we call the standard window. So if you hit your zoom key and number 6 where it says Z standard, that's zoom standard. This will give you your standard window, okay, for your graph. Well, if you take a look at what has happened, well, sure enough, this has gone to the left 1, 2, 3, 4, 5. It looks like the bottom of my parabola is at -5. So if I go to graph this, 1, 2, 3, 4, 5. Now if we remember with parabolas graphing, we have this 1, 3, 5 pattern. So since there's no number in front of the x, as I go to the right 1, I go up 1. As I go right another 1, now I go up 3. As I go right 1, now I go up 5. 1, 2, 3, 4, 5. Do the same thing going left, and I get my points. Have a nice sketch of my parabola. Now, I need to graph the other one. Well, y equals 9, that's just a horizontal line at 9. So now, when I look at this particular graph, it asks you how many solutions do I expect? Well, I expect 2. It looks like they've intersected at 2 different spots. I have one right here and one right there. So I expect to have 2 solutions. So looking at my solutions for x, it looks like x is at, down here at -2, and over here it's at -5. Let's see, 5, -6, 8. Looks like it's at about -7. Now, to actually find those algebraically, you're asked to solve the equation. So to solve this algebraically, notice how I have x plus 5 quantity squared equals 9. We have to undo a square. So the inverse operation of a square is a square root. I'm going to try to change colors because that neon green might be hard to see. So I'm going to take the square root of both sides. When you do that, do not forget the plus or minus. Because if you forget the plus or minus, you'll forget half your answer. So square and square root undo each other. So I'm left with x plus 5 equals, the square root of 9 is 3, but again, don't forget the plus or minus sign in front of it. So then, the last thing that I have to do is subtract 5 from both sides. So when I do that, 5's cross out, x equals -5 plus 3. Well, -5 plus 3 is -2. -5 minus 3 is -8. So going back to this graph, Mr. Bartz didn't go over. He needed to go over one more here, and he should have been at -8, not -7. And that makes sense because from 5, you want a distance of 3 to the right and 3 to the left. So we have our 2 solutions. You can always go back and check. -2 plus 5 is 3. 3 squared is 9. -8 plus 5 is -3. Negative 3 squared is also 9. So it's always good to check your answers. All right, number 2, same process. It says, sketch the graph of this equation. So on my calculator, the top part here, I'm going to put in as in y1, and here I'm going to put in as my y2. So I'm going to go to my calculator. So I have my y equals. So I'm going to clear out that equation. I'll even go to the second one and clear it out. So now I want to type in square root. So second next to the negative, so I get the square root symbol, x plus 5. Then I can go to the bottom. So I just want to make sure that is all under the radical, which it is. And then I have 3. I'm going to hit graph. Okay. So there is both of my equations. So that x plus 5, notice how my curve has moved, okay, to all the way over here. You can kind of see how I'm circling it here, to negative 5. And I have my curve. So negative 5, 1, 2, 3, 4, 5. And just like the parabola, it just does the reverse. Instead of going to the right, you go up 1, right 1. Then you go up 1 to the right 3. 1, 2, 3. Up 1 to the right 5. 1, 2, 3, 4, 5. If you want to do another one, you go up 1 and go all the way to 7. And you get your square root curve here. Then we also wanted to graph y equals 3. Well, that's the line or horizontal line at 3. So I have my graph. So in this particular case, we only have one solution. It looks like this solution is at 4. So we're going to solve it algebraically. So to undo a square root, we are going to square both sides. So square and square. Square and square root undo each other. So x plus 5 equals 3 squared is 9. Subtract the 5, x equals 4. Double check. 4 plus 5 is 9. Square root of 9 is 3. Matches up with my graph. It looked like it was at 4. So it looks good to go. Number 3 here. Absolute value problem. And we give you a doozy. So we're going to enter this in as my y1 and here as my y2. So let's go to our graphing calculator, go to our y equals, and let's clear out that first graph again. I'll even clear out the second graph so we can start from scratch. Of course, it helps if the clear takes. There we go. Back to the y equals. So I want to go 2, and then I want to do absolute value. So to get the absolute value, hit your math key. Whoops, it helps if I hit my math key there. So I hit math. If you go under number, you'll have the symbol that says ABS with parentheses. Now, depending on your calculator, when you hit ABS, it's either going to give you the bars or it's going to stay ABS. But you want to put everything that's in that box, you want to put this x minus 3 in right where this box is. So I'm going to type x minus 3. Now, to get out of that, see how it's giving you the right arrow symbol? Hit that right arrow, and then now all of a sudden it looks exactly what you want, plus 3. In the second one, put the 1. Now, if we remember, absolute value graphs are going to look like V graphs. This one's doing a couple interesting things to it. So if I hit graph, wow, I have this V graph way up top. Notice how it looks like it's at the point 3, 3. So if I go to sketch it, I go to 3, 3. There's my vertex. If I think about this x minus 3 moves it right 3. This 3 caused it to go up 3 from the origin. Now, because of the 2, normally it opens a 1 to 1, but it actually opens 1 to 2 because it's being multiplied by that 2. So we're going to go up that way each and every time. Now, my y2 equation is equal to 1. So I have that graph right here. And notice how these two do not intersect. So we should expect to have 0 solutions. Well, how does that show up algebraically? Well, how that shows up algebraically as we solve it is we want to get the absolute value piece by itself. Alright, so I'm going to subtract 3 from both sides. So I have 2 times the absolute value of x minus 3 equals negative 2. I'm now going to divide both sides by 2. So absolute value of x minus 3 equals negative 1. Well, absolute value means distance from 0 on a number line. Well, distance cannot be negative. Since it cannot be negative, there's no possible way you can figure out this answer. Absolute value, again, this represents a distance from 0 on the number line. Well, you can't be negative 1 units away, hence why you get no solution here algebraically, or 0 solutions. That ends your page 1. You can go ahead and turn to the back side.